As to the core modules, there are second most important modules in the repositories. Assembly assembles everything and consists of high-level configurations and settings, whereas core module is used for all the things shared between all of the other modules. So this could be templates for class templates that can be inherited later on. It involves a, for instance, there is a general mutation that is written in core module, where all of the mutations go through that general mutation in the core module. It also involves definitions of signals, some core modules, core features as login, authentication. So that's for backend, but for frontend, it involves templates for components such as searchers, filters. You would mostly build openIMIS on those kind of components, because as you can see, it is not. I've turned off the backend, so it will not. Yeah, but it is not in the terms of UI and visual things. It is not that complicated on front end. So you have basic components that you would mostly use, and those are defined in the core module. Of course, then used in the different modules and tailored for your needs, depending on what you want to achieve using those components. That brings us to translations, but it would be we can start with the translations for backend. Hopefully, most of you have local instances of modules on your machine. So we have, in openIMIS, we have translations on frontend, which is obvious, and translations on the backend as well. So to help to organize those translations, there's been a script that's responsible for gathering all of the string IDs in one file. And that helps with, you don't need to do it manually. You have all of the translations in one file, and they're gathered automatically. So let's say I want to see the translations for the task management module. So it looks like that. Let me actually delete the, or maybe let's find the that part in the code. So let me find it in the code. So we use message IDs and put them in the place of the strings. This one is used for validation of existing user. Then after we create that ID, we can execute the script that is described here. So from your module root directory, execute following command. So I will go to the tasks management module. So I'm in a root directory. I will remove that localize folder, and I will try to execute the script. It might be in a different place that it used to be. So let's verify this. So it is in the script. Not found. Let me think for a second why it didn't work. In task management. And let's see. I deleted that locally directory. I executed the script, and it created a new directory with the string IDs gathered in one place with comments where all of the occurrences of those IDs exist, and places where I can state the translation. Remember to delete the init.py from the from that folder, because it is later on treated as a Python package, which clashes with a different package that is called get text or something like that, and it causes problems, so it should be deleted. I will go back to the develop branch. I will reset it to the default settings. So we finished on the generating translations. What I showed you was to generate the file that consists of string IDs and their translations. And it gathers all of the string IDs from the module and puts them in a one file. However, you could do the same thing with already existing file, because I deleted that file. If I let's say I remove those last two translations, and I will execute the same script. It should update the existing file. You can see that it added comments to translations that already were included in that file, but were added manually. So it added the comment with the place occurrence in the code. And here it added those two translations that I removed from that file. So it is a really neat tool for managing those translations. Let me just roll back the changes. Let's leave it as it was. Another thing that is important to remember when adding the translations is to add them to localize. Localize is a tool that stores all of the translations, key translations and translations online. And depending on where you want to add a translation, I want to add it to the openIMIS backend. I just add the key and translation here, so everything is in one place. The same works for frontend. However, managing translations on frontend is a little bit easier. So let's say I want to go to a random module, and go to the translations. You might find the translations structured this way, but eventually it all gets flattened. So you could write that the same translation in such way that it looks like invoice dot page title, and so on, so on. So some translations look like this, but maybe if I will go to other module, you'll see that, yeah, it is structured that way. And here even there's a mix of those two types. You to use those translations in front-end modules. Let's find that translation in the code. Maybe different one. Um, I'm not sure why it does not find it in the code, but we could just go to any component and we'll find it anyway. Maybe the format. Okay. So to use translations on frontend, we have two functions that allow us to do so. It is format message, just format message, and format message with values. You would need to pass required parameters alongside with the module name and translation ID, and then for format message with values, you would provide the arguments for the translation, and for just format message, you would provide the string ID. So if we were to find those those translations, you can see that the argument is defined like this in the parentheses, and it needs to be described as a argument in a object, JavaScript object. Okay, so we can move to the structure of backend module. It consists of admin, depending if you want to add that to Django admin panel. There's, to my knowledge, there's none of the modules are managed from the Django admin panel. The only thing that is useful for is managing the configuration. Let's go to a random apps file. But what it does, it provides the default configuration, and it starts the whole module. So we can stick with the task management. Let's go to apps. So we can see that you define default config for that particular module. Config usually consists of permissions for different actions in the system within that module, which permission is assigned to which number is assigned to which kind of permission. And then you load that config depending on if you overridden the config or not. So it takes that config unless it's overridden by the config provided by the user. And how you can provide that additional config is, for example, using Django admin. Let me just start the server. Okay, so to log into Django admin panel, we want to use a backend URL, so and the port will be 8000 API admin. We already logged in because I was logged in here. And there is a core module that provides the management for configurations, and I can add a new configuration here. I can specify the module. So let's say does management. I can specify which layer I want to use, for which layer this config will be used, because I don't know if you remember, but during the assembling of front-end modules, the configuration is also fetched from the backend, so it could be used on front-end and backend. Because some of the implementations, at least we tried for the most of the implementations to use the configuration to manage how openIMIS should look and how it should behave. In some cases, the necessary repositories are forked, but when it can be done through the configuration, the customization should be done through the configuration. The version is 1, and we can we put the configuration as a JSON, so it doesn't even need to be something that exists in the system, so whatever. It's exposed means that it can be exposed for the data. I'm not entirely sure, but I believe it's regarding you can access the configuration through an API call, I believe, but I'm not entirely sure. Better to keep the configuration not exposed to anyone. You can set that dates between what dates you can between what dates the configuration is available. You can save it. I made a mistake in the name of the module, so it will not be applied to the module I wanted, but I will not even run it. I just wanted to show you that you can manage the config like that using the Django administration panel. I will delete that. There are modules that are that provide more things in the apps besides the configuration. If I'm not mistaken, the injury is a module where more interesting things happen. So, I mean, it is still about the configuration, but the configuration is more complex, so it requires additional functions, methods to deal with that configuration depending on what you want to achieve in that module. Or you can help. There's a predefined function method that loads the config, but sometimes you might need to create your own method to load the config in a way that you want it to be loaded. And you can provide getters for some data. So it is probably used somewhere in a code, because most of the time you would access the configuration just like that dot and the parameter of the config. If you want to have more complex getters, you would also define them in that file. Okay, so another important part is models. So basically, everyone should know what a model is by now in Django, but interesting thing about models in openIMIS, some of them might not be managed, and it means that if you make migrations, use a script for making migrations, the Python manage make migrations, the migrations will be not automatically created for those models that are not managed. I believe right now there are not a lot of models like that, but it is possible to find them. Let's see if there are any managed false or okay. So at this moment there might be non-models that are not managed, so you should not care. So you don't care about creating your own migrations. They should be created automatically when executing the make migrations script. There are two types of models that you can find in openIMIS. It is history model. I think there's something wrong with my Python interpreter. That it does not recognize the Python. Okay, I'm not sure why it's not working, but it does not matter. I will just find it like that. So there's a history model, and there should be also a history business model. Those are new types of models, and for new development, those are the models that should be used. There's also a versioned model, which basically does the same thing as history model, but history model does it better. So it was required to create a new type of model that saves the history, but in more efficient way. So new developments are required to use the history model and business history model. The difference between history model and business history model is two fields which are valid from and valid to. So history model does not include those fields, but business history model. has those date valid from, date valid to. So it means that an object is valid from a period of time to a period of time. It doesn't necessarily mean that it needs to be valid to certain time. It can be valid for forever, but there's always a date valid from. Okay. I'm thinking if there's anything else I should tell you about the models. Yeah, regular models, foreign keys to different models. That's usual stuff. Schema. How many of you are familiar with GraphQL? Have you worked with GraphQL? It is a different communication type than REST API. It was developed by Facebook, I believe, to it fetches and creates data in a different way, which I think really works well with the openIMIS data. I can show you how it works. So let's say I will go to the insurance page. Why it's not working? Because the front end is not working. GraphQL is really convenient for getting complex data easily. You don't need to specify a particular endpoint for particular case. You can just define the schema for the module and for the model and the fields that are in that model, and querying fields that you need from the models that you need. I will show you in a second how it looks, but the front end needs to start. So let's go to insurance, and the front end sends a query that wants to fetch some kind of object, in this case insurance. We can intercept that call and see what happens in the request body. Okay, so sorry. GraphQL provides a tool for executing those queries and mutations within to get data from backend. It is available under API GraphQL. Okay, so this is what is being sent from a frontend to the backend, and this is what frontend gets from the backend. So I'm saying that I want to get first 10 injuries ordered by the ID. And I specify that I want to get their IDs, UIDs, validity from, validity to, all of the fields that I'm interested in. For instance, I could remove other names and last name if I remove that. I would get data without those fields. So this is how it looks. We'll create some queries and mutations while we will be developing a new module, because we will need to access and create some data. So we'll train doing that then. So yeah, the schema is a file that describes what can be taken from, for instance, injuries. So when we'll go to the injury module, we'll go to the schema. Oh, you know what? I will use a different module, because some of the older modules are written not according to the clean code policies and all of that. And I know that new modules such as task management obey the rules of clean code, and it will be easier to understand for everyone what's happening here. So schema defines a class query where we define what can be queried from the backend. So, for instance, if we wanted to query injury, you would call that an injury. But in this case, it's a task group. It uses ordered Django filtered connection field, which we'll talk about later on about regarding the core features, because it's a field that is provided by a core module that overrides a Django filtered connection field for the needs of openIMIS. You create GraphQL types depending on the module. So in this case, we are creating a task group GraphQL type, which is basically the mapping of a model that is a task group. This is a model of task group. It consists of code and competition policy. That's it. We map it to the GraphQL type, defining how we want to filter, what abilities we want to give for a client to filter. So this is also a great tool. GraphQL is a great tool for things like that. If you want to filter easily some fields. So if you wanted to filter by let's say it's an injury. Okay, so validity to it is a standalone field, but adding a dash and filter option, we can filter the injuries by validity to lower than some kind of date. And this is where you define those filters. You tell which are allowed and which are not. We saw that the task group consists of only code and competition policy, but it inherits from the history model that we said that is the modern way of using models in the openIMIS. And because of that, we can add filters to the fields that are provided by that history model. And once it's defined, we defined how we want to resolve that query by defining the method that it will resolve the query that starts with resolve. It will be recognized by GraphQL as a method that is used for resolving task group. So here you can see that it involves some kind of filtering, and it returns a query of those models, of that model. There's another part that is regarding mutations. You specify mutation is a way of creating, deleting, and updating objects using GraphQL. In the schema, you define those mutations, and you tell the API how you can access those mutations. So you give them a name. So you create a mutation and then give them a name, and GraphQL creates a documentation for you, the API documentation. So it is called create task group. If I type that here, task group, I'll have a definition of mutation for the task group. I can see what is acceptable in what parameters are acceptable by that mutation in order to create a object. And the last thing that is important when it comes to the schemas, besides defining the queries, which is defining how you fetch the data, defining the mutations, which is how you create, delete, and update data. You have a bind signal method, which is not implemented in this module, but it is implemented in, for instance, claim schema. So I said before that there's a one mutation that all of the other mutations in modules are using. And this mutation is using signals. I mean, the definition of that mutation send signals, Django signals. I don't know if you are familiar with Django signals, but signals are pretty cool way to communicate between different parts of the code without using actual functions being called. So there are 3 times where those signals are being executed during the mutation. And you can define, in bind signals, you can define what should happen during those signals. So let me find the here. There are 3 places where the signals are emitted in that mutation. So during the mutation validation, the signal is sent before mutating and after mutating. So you can specify what should happen before and after the mutation and during the validation without putting actual code in that mutation, but in that bind signals, you specify the function and you send the information on what should happen through that signal. In this case, it impacts the claim query depending on. It does something. Oh yeah, I know what it does. It creates his. It creates information in the database that the mutation has been done for that particular claim, which is useful for a couple of reasons that we'll discuss later on. Okay. And the other important part of the openIMIS module is a file called signals.py. So as I was saying, signals are second another approach for the event handling in the application. They were developed later than signals for GQL functionality and can be used not only for the GQL actions, but also for anything that have signal attached. So initially, those signals were used only during that mutation, but someone decided that it would be good to have them to use them in different parts of the app as well. So I will show you how they are used. Example of how they are used. So let's go to the task management. I will use task management as a reference a lot because it's one of the newest models and it's up to date with the current guidelines on how to develop the module. Let's go to signals. Oh, sorry, to services. And there's a wrapper that wraps a function or class method with a signal name. And once you define, once you bind that name of the signal in a module, it will, everywhere where it binds, it will detect that this service has been executed. It sends the message that this service has been executed. And something happens, and something should happen once you define once you bind the signal with what should happen, this thing will happen. So in this case, oh, here we have a resolution of what happens when a task service resolve task is emitted, which is a good thing for modularity, because if the service is not, if the module that emits the service is not available, it will be never executed. For front-end, we already talked about translations on front-end. I showed you the format message with values and just format message. Index is a kind of like apps in the backend module. So let's go to the index file. But not exactly like apps file, because it gathers the information on different contributions which we'll talk about later on, what contributions are, and the references to the components, which is a key that is assigned. You assign a key to a component to be used somewhere outside a module. So this is a file where you specify the routes, where you specify the main menu contributions, you specify the reducer, translations. It's kind of like a configuration file, but without having a actual configuration coming from the user. Actions. Actions are files that consist of creating queries and mutations, so request bodies to be included in the request for backend. So if I want to get injuries, if I want to get tasks, and I want to execute that request in a code, I would define how it should be structured in that file, and then use it in a component or a different file, and it will be executed and sent to the backend. Okay. So components. I was saying that openIMIS is a pretty simple when it comes to the UI, when it comes to the visual aspects, because once we will go through, it is mostly the same thing. It is a searcher and a filter pane. We don't have data for that, but let's go to the injury. There's a searcher, there's a filter pane. Once we go and see a particular object, the data is displayed in a similar way. This one is pretty fancy because it involves a photo, but all of the components are pretty similar to each other. So that's why you can we can, how it's called, there's a certain structure to those components. So most of the time you would use a searcher that uses a searcher that is a core component, and you would describe, you would specify the things that need to be done around that component. So you specify headers, how it should be sorted, how the item is formatted. So it is a pretty structured way to develop on front end. Every searcher needs a filter, so it always consists of a filter. The flow is basically the flow basically starts with a page. The page for searcher for queried objects that display a lot of data, and then individual object page. So we have a task tasks all page, which leads us to a searcher, and we have task detail page, which leads us to a form, which is also one of the core components that is used to display and to create objects in the openIMIS system. The form consists always of head panel. The head panel is, let's go to here. The head panel is that part that displays the data for the object, and those panels under are customized to display something else. Pickers. There's actually a lot of pickers in the openIMIS. There's also there are core components for utilizing pickers. So most of the time you would just select a picker, copy that, and adjust that for your needs, depending on what you want to achieve. Sometimes you could see this type of formatting a GraphQL query, which is fine, but it is better to create those queries in a structured form as in the actions. Published components. So those are components that let me find. Published. So published component is a component that gets a key and other props that you would like to pass to that component. And the things that you saw in the index under the refs, those are the keys to those particular components or even functions. The benefit of that is you can use those components between the modules. You cannot use a direct reference to the component in a different module, but when you use a published component, specify the key, you need to manually add the key for a component. So if it was fetch task 1, I would need to manually add the reference to that. And if the module is not existent in the code base, the component will be not executed in that published component. So it prevents from unwanted module calls. And there's also contribution key, which is, to be honest, none of the developers know the difference between contribution key and published component, but I know the difference. The difference between published component, basically it can serve the same thing. So you could use a key for a contribution to display a component. But the main difference is that for published component, you can use just a one particular key. We are thinking about just a one component. Contribution works as a point where you gather all of the components that need to be associated with that key. So it's a good thing to use in menu contributions. So if you want to include another piece of a menu in that menu tab, I'm talking about when I'm displaying claims, I would like to add another part of that menu. I would register it under a menu related to the claims, and it takes all of the components that are related to that key and you can use them and you can get what you need, or you can display all of them. So that's the main difference. There's a lot of places in the code where contribution is used as published component, which works, but it is better to use the published component because it was intended to be used in such a way. And I think it's a good place to finish for today. And if you have questions, we can have questions right now. Do you have any questions regarding what we are talking about, regarding those parts of the modules, front and back end? I know it can be a little bit abstractive for now, since you don't have experience with working with those components. Just talking about them might be a little bit confusing, but I believe it's good to know at least a little bit before starting to work with them, to get the idea of what they do, and have a overall knowledge about the system.
Thank you. Can you go back to the models in the back end?
Mm-hmm.
Yes, thank you. I want to understand the models are are a class, the classes we are implementing the tables.
Yes, so models are actually a representation of what we are storing in a database.
Not what we are saying in database. I mean, how the database is. You are using code first. That means you are making a class with the database field, with the table fields, and for example, the entries. I would like to see the table of the entries and how it's look like on the models.
Okay, so you would like to see the actual database entry of the entry in a database, right?
Yeah. Okay. We have
Okay.
auto field. We have DB column is entry ID and this primary key. Okay. And we have inside also some business logic.
Yes, I believe those serve as a getters for so it does not store the age, it stores just the birthday. So using that getter, we can calculate the age based on the birthday.
Understood. And now this is the model. And if you talked also in the GraphQL about some mapping. We have another model, DTO, data transfer object, that's used GraphQL. Where is this model in the backend?
So it is done automatically. So the GraphQL library package provides, let me, schema. No, let's go to entries. So we'll talk about a particular example. Let's talk about entries. We have schema. And schema defines entries using the entry GraphQL type. So this type inherits from Django object type, which provides necessary tools for mapping that model for the GraphQL type. So you specify the model in the meta class of the injury GraphQL type.
Mhm.
And it automatically allows you to use fields from the model to be used in the GraphQL. And here you specify what kind of filters you apply to those fields.
Okay, and the ordering is happen on the DB, or the GraphQL is, as I understood, GraphQL is middleware between the between the front end and the back end. And we are, for example, asking, give us the entries and order them age. The ordering is happen on the DB or is happen on the GraphQL?
I believe it happens on the order is depending on the query. So the query calls directly a database depending on the query params. So if you say that query, let's go back to the entries and resolve injury. Resolve injuries. This is where we specify where we filter a query. So all of that code is adding filters, is gathering the filters, and at the end it gives those filters to the
Query.
query. Yeah. And depending on how it will be filtered, depending on how what the filters are, it then the Django ORM communicate with the database, and depending on that, it gets the data from the database in that order.
Yeah, in that order, because at all is at all it's like to array or something like that. It's
exactly.
Yeah. Okay, great. And we spoke about the models, the query. And what is the difference between the scheme and the service?
So the service is used for when you try to the scheme. Schema is a file that consists of a query class and a mutation class. And a query, in query, you just query the items, you just get the data. And mutations are used for creating, updating, and deleting. And to create some kind of clarity, maybe if the data manipulation is more complex, and to be aligned with clean code practices, we move the logic for those processes, such as creating, updating, deleting, or something else, to the services. So you call the mutation, which is, let me show you the mutation. We call a mutation, which is responsible for communicating with the client and the server on that we want to create something. Let's say, because it's a create task group mutation, we perform logic within the mutation that should be done for the mutation. So we clean some data, we validate if the user has access to this kind of task, and then we move the logic for creation to the service. And services are places where you describe what should be exactly done to that object, or to how to create an object, or how to delete that object.
Okay, can you go inside the create service?
Yes.
Thank you.
So in the mutation, we point to the service that this should happen when the create mutation occurs. We want to use service for creation of a task group.
And now, if we go with the timeline first, what will be called first? The service from the front end to the back end.
Once we have a call from a client for mutation, it will first go to the mutation, and then from the mutation it will go to the so it goes into the actually it goes to the schema mutation. Then it recognizes that it's a create task group mutation. It goes to the mutation. It executes the mutation, and finally it goes to the service. But those mutations are children of different classes that define mutations, and they all end up in that one openIMIS mutation that we were talking about regarding the signals. So I will go to that. Too bad I can't use that interpreter to go using control. So I need to use double shift. We go to the openIMIS mutation, and this is where this is the most basic level of the mutation. It goes into here first, and it executes all of that code, sending the signal before the mutation, and then it uses the method that is provided by the higher level class, async mutate. So here we have mutate. The base mutation use it is called in the async mutate, which is called in that lowest level mutation. Sorry, I lost it. Here. So every mutation goes through that process, and depending on how the async mutate is defined, this will happen.
Okay, thank you.